If you found any issue related to this video, write your queries in the comments box below. Let's keep building your MATLAB foundation and solve the issues together. Don't forget to check out our next videos for more advanced techniques and share your thoughts in the comments below. And please don't forget to like, share, and subscribe the channel. Let's start the lecture.
All right, let's talk about something that's probably causing a lot of headaches right now. Why your trusted Simulink models might be completely broken after upgrading to MATLAB 2025b. Let's dive right in.
So, picture this. You've just installed the latest and greatest MATLAB R2025b. You're excited. You open up that one trusty Simulink model, the one that's worked for years, and bam, it's completely broken. If that's you, trust me, you are not alone, and we're about to get to the bottom of exactly why this is happening.
The Simscape electric specialized power system library and its conversion assistant have been removed. If your models use Powergui Universal Bridge or other SPS blocks, they won't open in 2025b. I will show you exactly why this happened, how to confirm it, and the practical ways to migrate your models, including which Simscape blocks and solver setup replace Powergui in the new workflow.
And this is probably the error message you're staring at. It's a bit of a shock, right? It even mentions a conversion assistant, which sounds like a lifeline, but as we're about to see, it's not nearly that simple. The really crucial part here is that a fundamental piece of Simulink has just vanished. So where did everything go? It's like a key part of your toolbox just disappeared overnight. In this first section, let's play detective and solve the mystery of the missing blocks. And trust me, this is where the story gets pretty interesting. You pop open the library browser, and you immediately notice your go-to blocks are just gone. The core components of the Specialized Power Systems Library, or SPS, are missing. We're talking about things like the Powergui block, the universal bridge, even basic stuff like current and voltage measurement blocks. They're nowhere to be found. It seriously feels like the entire foundation for power systems modeling has been ripped out from under you. And that's because, well, it has. This isn't a bug. You didn't mess up the installation. MathWorks made a very deliberate, very intentional decision to completely remove the SimPowerSystems library from MATLAB, starting with version R2025b. So where did it go? They didn't just hit the delete key. The technology was actually transferred. The rights for all of its development and support now belong to a totally different company, Opal RT Technologies, who specialize in real-time simulation. So, they've taken over the classic SPS toolbox and are going to be releasing it as their own product. Okay, to really understand why MathWorks would make such a dramatic move, we need to rewind a little bit and look at the history of how electrical modeling worked in MATLAB. For a long time, it's really been a tale of two parallel and frankly incompatible toolboxes.
For years, MATLAB basically had these two parallel universes for electrical modeling. On one side, you had SimPowerSystems, SPS, which was built specifically for power engineers. It had its own boss, the Powergui block, and its own way of doing things. But then on the other side, you had the more modern Simscape Electrical, built on a much more general-purpose physical modeling engine.
MathWorks' goal was to finally end this split personality. They wanted one single, consistent modeling approach that uses that powerful modern Simscape engine. The one that understands physical units, allows for cleaner modeling, and integrates better with hardware. The old SPS library just didn't fit into this new vision.
In old version or in specialized power system, we are using either continuous or discrete for simulation mode. But in Simscape Electric or new solver configuration, it can be handled by Simscape solver. In SPS, we are using FFT tool to analyze FFT fast Fourier transform. But in Simscape Electric, we will use spectrum analyzer. So we are using Powergui for initialization, but for physical model, we will use solver configuration. The load flow analysis and steady state can be analyzed and built using Powergui in SPS. But in Simscape Electric physical modeling, the initial condition of the blocks can be used for steady state analysis or load flow analysis. So we can change these initial targets. In SPS, we are using ground, but in physical modeling, we will use electrical reference.
But wait a minute, I can hear you thinking it now. The error message, it mentioned an SPS conversion assistant. That sounds like the magic button we all need, right?
Why can't we just run it and fix our model automatically? Well, this is where things get really confusing.
Here's the core of the problem, and it's super frustrating. In R2025b, the file for that conversion assistant, it's physically there on your computer, but MathWorks has blocked public access, which makes it totally unusable. And if you go back to an older version of MATLAB to try and find it, it's not even there. So that automated helper the error message points you to, yeah, it's a dead end.
So if the old library is gone and the automatic converter is a ghost, what's the solution? Well, you have to learn the new rules of simulation. And honestly, it all boils down to understanding 3 essential new blocks that replace that entire old workflow.
First up is the solver configuration block. Think of this as the new Powergui. It is the manager for your entire physical network. Every single Simscape network needs exactly one of these blocks. It's what tells the simulation engine how to solve all the equations and how to get the system started.
Next up, the electrical reference block. This one's super simple. It's the new ground. That's it. In the old SPS world, you had a ground block. In the new Simscape world, you need an electrical reference block to provide that 0-volt point for the whole circuit. Your model literally will not run without it. And finally, we have the converter blocks. These are your translators, and they are absolutely essential. See, Simscape physical networks and standard Simulink signal networks, they speak totally different languages. If you want to view a physical current on a regular Simulink scope, you have to use a PS2 Simulink converter to translate that physical signal into a signal that Simulink can actually understand.
So understand the use of Simulink PS converter and PS Simulink converter. Is this one is taking a physical signal from Simscape back into Simulink, while the Simulink PS converter is sending a control signal from Simulink into a physical system.
Okay, so we've got the new rules, we know the key players. Now let's put it all into practice with a step-by-step guide for actually converting your old models.
This right here, this is the slide you're going to want to screenshot. This is your direct translation guide. Where you used to use Powergui, you now use a solver configuration block. Ground gets replaced by electrical reference. Your old measurement blocks are now sensor blocks. And a complex all-in-one block like the series RLC branch, well, now you build it from its fundamental parts, an inductor, a resistor, and a capacitor.
So, your manual workflow is going to look like this. Step 1, delete the old Powergui block. Just get it out of there. 2, add one and only one solver configuration block to your network. 3, add one electrical reference block to be your ground. 4, and this is the big one, methodically go through and replace every single old SPS block with its new Simscape equivalent. And finally, step 5, wire up your scopes and displays using those essential PS to Simulink converter blocks.
This whole transition is really more than just swapping out a few blocks. It's a complete shift in philosophy. That old Powergui was like a Swiss Army knife. It did everything. It handled your solver choice, your FFT analysis, your load flow. It was all in one place. Now, those jobs are handled by the powerful Simscape solver and dedicated blocks like the spectrum analyzer, or by setting initial conditions directly in the blocks themselves. It's just a more modern, modular way of doing things.
Look, I get it. The initial shock of a broken model is frustrating, but the path forward is clear. It requires adapting to the modern and, frankly, more powerful Simscape environment. The big takeaway is that this change, while definitely disruptive, moves everyone toward a much more consistent and capable platform. So now that you know the new rules of the game, how are you going to adapt your models for the future?